Nah, broadcasting. I guess. Yeah, not for good reason. I don't think I have a good reason. But anyway, yeah, I figure I can play some more Ken video and just complain about people in physics. Bad physics. The whole idea of what, how this really shouldn't be as complex an argument as it's become. Um, and certainly I think I could say something about this difference between ether theories and the truth, or what physics is even moving towards, conventional physics. In a sense, they're conceding some of these points in a way. They're just not going to say it's. They can't concede the idea that dead ether just doesn't work. So they're that part of that physics just can't work. Um, yeah. So they have to make a field of something. Um, it's kind of funny just because the people with field theory, you think they would just recognize that gravity, it has to be functioning in the same way, and they just haven't made that connection, which is just very strange. They could fix the idea of a bunch of locations in the universe, and each location having um, a direction, an orientation, is it sort of makes sense. I mean, I guess it still doesn't fix like I said, they just have to recognize the polarization thing, the fact that there's more than one bit of information at each location. So it's not just about where that location is moving, it's about what is moving at that location, in terms of what clothes is it wearing, the thing that's moving. Probably need a better analogy than clothes, but uh, I don't know. It's not that bad. It's kind of boring, I guess. So yeah, you want something a little more interesting, um, but it doesn't really matter. I mean, it'd be nice to have something that would be impossible for nothing to be in. So it's like it could never be empty. And that way people could understand that something always has to be wearing the suit. The only way the suit goes a different way is somebody steals it and runs a different way with it. So maybe you could think of it as whether it's, you know, whether the quanton is carrying a purse or a wallet, some other way to make the comparison. And the only way the wallet changes direction is something has to steal it and run with it. Yeah, it might be a good way to say it. So anyway, but it's kind of funny that it's the same universe, same facts that everybody has to work with, and you have these completely so different that people will call each other insane, if they don't agree. Kind of interpretations of that evidence. And so that in itself is probably worth much conversation, especially considering, um, how little evidence swings the vote one way or another. A tiny problem is enough of a problem for fundamental decisions like push pull or wave particle to be decided. Just because nobody could come up with a rational explanation for the interference pattern, the simplest pattern in the universe, on off, and because nobody could, in a timely manner, construct a better theory of what was causing it, yeah, they just decided to turn the simplest thing in the universe into something doing complex wave mechanics as if it was traveling through an ether, through a medium, and doing it in some kind of bizarre manner where, unlike any other wave in the universe, the energy of its radar didn't cost it anything. It could scan the entire universe in front of it, collect information, and somehow then decide where probabilistically it was supposed to go. All just so silly. And smart people fell for it. And you're just saying, how, that in itself is a subject. I mean, how could smart people fall for such a fantastically silly explanation? First, the photons split in half, where they never do this. They've never been found to split in half in any other circumstance. And that they're doing it in a single slit experiment, which is even funnier or sillier. But then again, they came up with this patch for the single slit of Huygens, this little bit of fakery to explain how they can make one photon into two. But it's just such such an obvious contrivance, making two waves in a single slit experiment. So even when there's not the obligation to explain two slits, and even so you have this convenient opportunity to decide to make two photons and create two waves. In the single slit, you have no opportunity to do that. And they were so glued to it, they were so sure that this must be the truth, that they contrived an excuse to turn the single slit into something making two waves. So they could do their interference thing, so they, wouldn't explain a simple pattern, on, off, on, off, on, off, simplest pattern you can make, into, wave mechanics. And it's just amazing that that's what all this, the whole platform that they built. This is the foundation, the timber and the cement and the nails and the hammer. This is what this is their outline, and you can see that the hammer doesn't have any thing on it. The nails have no points. The wood is, Swiss cheese, and the cement is oatmeal. I mean, it's just a horrible pile of slop as a bunch of axioms, or as a something to build physics on. Once you open the door to all these extraordinary functions being possessed by the simplest thing in the universe, then it's just going to be too easy to just keep making up new fairies. And that's quite tragic, and all of that mush that, like I said, that smart people could be fooled, and that just kind of amazing to think that nobody in 100 years, nobody that we know of, nobody who could gain any traction. I'm sure there's been some people who said, look, this is silly. I don't know what the right answer is, but I know this is the wrong answer. And of course, it's easy to ignore them because they don't have a replacement theory. They don't have an explanation. And so you can't just fight on the fact that what they have is wrong or nonsensical. You have to replace it with something. And even if you do replace it with something, we'll see what happens. I mean, I'm replacing it with something and I'm not gaining any traction either. So, maybe that's the way it'll work. They'll just remain ignorant by volition, or something like that. So, but yeah, it's sort of an amazing story. So anyway, so there's this whole, I'd say it's the largest group of science truthers, or science skeptics, physics skeptics, non-traditionalists. I don't know what to call them. I mean, I don't think it's all, I don't think it deserves entirely derogatory language like pseudoscience or snake oil science or all that kind of stuff. But some of it obviously is because clearly there are people who are selling a story, and they're deliberately ignoring when somebody makes an argument to them. They deliberately ignore it, like truthers. When somebody explains one of their truther theories to be made out of shit, they'll just go out the next day and repeat the same lie, even though they know that lie doesn't have any teeth. Well, that story doesn't have any integrity or validity because it has been debunked thoroughly. So those kind of people are just evil. Now, what category you put a person like Ken in? I mean, so clearly he's connected to this whole electric universe idea in a sense. He doesn't use the same rhetoric as many of them, but it seems pretty clear that that's what he's talking about. And, it's based on this idea that there's this ether, okay, which is a field, presumably. I guess it's you can't do much with something that's counter space, space and counter space. That's a little bit messy. So I don't know whether the ether is the space or the ether is the counter space. I mean, I imagine it has to be the counter space because I think by their definition, space would be a purely non-active player, and it would be the counter space that is somehow the medium through which something is transmitted. But that's his description, is always relating it to some kind of medium, except when he says it's like a coaxial cable. That part is a little bit difficult to understand. Well, it's impossible to understand. But he uses examples like waving your arms and then water waves. And he used water droplets as an example. And so these are all force conversions. Force goes into something, creates an effect, and then that effect can be received by something else as a representation of the event. And so the waves created by a drop of water are a bird dropping dead and falling into the water, or bird shit falling into the water, or a meteor falling into the water, or I don't know, an engagement ring falling into the water, or an ex-wife falling into the water. Whatever it is that's falling into the water, you can receive the information, so use a Puro kind of term, that is a representation of that event, in the sense that the event will catalog, will create other events that will carry substantial information regarding what that event was. Not necessarily detailed information, not complete information, but enough. Sort of like sonar. I mean, it's not going to give you every detail, but it'll give you some idea that there's something in the water over there, and give you a direction and some information regarding properties. All right. So the underlying thing is that however you explain the fact that these cause and effect events are happening, and so I mean, there should be agreement that a light bulb turns on, that there's movement, there's stuff changing, and the change creates this new thing that comes off of the light bulb. Now, whether we call that a disturbance in a medium, or we consider it a actual stuff moving, stuff changed. I mean, stuff carrying, wearing hats instead of not wearing hats, carrying wallets instead of purses. Um, there has been an exchange, you could say, made. I mean, that would be my argument. Something's been exchanged. Something's changed. There's nothing created. There's just something changed. And now the field is recognizable. So it's like the difference between signal and noise. So you can filter signal out of noise. You can have a very choppy sea and still send a wave through it and still receive it somewhere else if you know what the frequency of the wave is. And so you could still collect the information even though it looks like the information is lost in the chaos. That kind of thing. And how to equate this? I'm just trying to get to the point of what, the whole argument of defending some territory as if we can't call this an ether and we can't call this other theory, so the particleists, are going to have a hard time saying, okay, this thing's made out of stuff that's moving, and somehow you're going to call that an ether. Well, that's not going to work. So, like, from my perspective, it wouldn't be really right to call something that's an active field, in the sense that it obviously has an ability to, it already has built into it so much movement, that's creating gravity, a huge amount of pressure. So to say that the ether is a choppy, active thing doesn't really go with ether theory. I mean, it isn't easily understood that if you make a checkerboard, you don't make a checkerboard where the squares are moving, and they're changing color or something like that. It doesn't fit with the model of a structure that allows things to move through it, because it looks too dirty for that. But like I'm saying, it's not necessarily incompatible in the sense that you can have a noisy medium, medium doing many things, not just one thing. And so Ken sort of alludes to that when he just kind of talks about how the ether has modalities, I think is the word he uses. But, because it's manifesting these different kinds of phenomenon. So I guess he's conceding that there's a difference between a photon and sound waves, and maybe even, I don't know. I mean, he says there's no such thing as an electron, and I mean, that's just such a hard one to realistically. I mean, I can't make much sense out of how you can deny that the existence of those rather substantial elements. I'm saying, I mean, there's so many experiments that kind of demonstrate this thing of much greater mass than a photon, and it's moving at variable speeds, and having all these capacities to create different phenomena. So that sort of gets to the key thing, which is where conventional physics is sort of conceding an element of Ken's argument, and yet he's not. If the ether people would bend as much as conventional physics is bending, in the sense of creating things, are talking about ideas like virtual photons, them arguing that it looks like particles, is almost them saying it looks like what would happen also if the field was made of dominoes and they constantly pop back up and you could just keep knocking them down, and the field is this idea of these dominoes just constantly doing this perturbation, this progression through the field, and they're doing it in this straight line. So it's a wave in the sense that the dominoes have a certain pattern, wavelength and such, but it doesn't spread. I mean, that's the problem here. You use the word like wave. Wave implies a spreading, and it just doesn't quite work that way, except for photons. Except when you get into something like radio waves, where the way you're admitting them is completely different. Light is emitting little rays of intense, closely gapped energy quanta, and radio is doing this much different thing where it does actually release a huge number. It's a giant. Well, look, you can just do it that way. You can just say, well, a radio tower is, about, I don't know, more than a million. I'm thinking, I don't know, 500 million times bigger than a light bulb. So obviously it's the way it's radiating the energy is in kind of waves, in the sense that there's so much of it, it creates a wave front. And so it's not so much about the rays of energy anymore as it is just the huge density of the amount. And I guess in a sense, waves always do this too, so it doesn't really matter. I mean, waves diverge. Once it's not a flat wave, it's going to diverge. So radio waves tend to diverge based on how they're admitted, and they're usually admitted from like a point source kind of perspective. So they will tend to spread as they go out, like a bubble. So it looks like a wave when, I mean, it certainly can have more of an appearance of a wave. Light would have that appearance, I suppose, if we could see it the same way we can't see radio waves, but we can think about them and understand that the cycle is so much slower that we can sort of get the mental impression. And they draw it that way. I guess that's part of it too. We've all seen it as kids. They draw a radio tower with the lines coming off of it like waves. And they don't do that for a light bulb. Light bulbs are usually straight lines. And so it's maybe just those symbols are fooling us. But I mean, in a sense, light bulbs are doing the same thing as the radio tower, because the photons aren't being released. Not only do the photons have their own frequency, but the existence of the little rays, you could draw the rays and just have a break between them, and then rays, and then a break, and so it'd be like dotted lines. And the dotted lines would end up having where all the gaps are would be another wave, because the 60 cycle electricity is producing another wave on top of the frequency of the light. So there's more than one component of change or difference. Anyway, that's a long way around. I'm just trying to get to the point that when they come up with virtual photons, they're describing, well, it's an accurate description. So they're explaining what exists. And what exists is a force that looks like a straight line force. It behaves like photons. What magnets are doing looks like, light bulb energy, in the sense that the North Pole is producing one kind of light, the South Pole of the magnet's producing another kind of light, and they're all straight lines. And where those force lines, where those photons intersect, anything in that area of intersection is going to have a complex relationship, because it's going to feel both, perhaps, a force created that will be called attraction, and a force called repulsion. It's all going to be repulsion in a sense, but the repulsion is from the field energy. So I mean, the attraction is really made of the pressure, the absence of repulsion in between the two forces. The forces create, the thing is creating a force that is benign to the other thing, so it can't be affected by it, and vice versa. And so if you change something where I only react to quanta wearing hats, and you shine a light bulb at me that, and all the photons aren't wearing hats, then it's invisible to me and I won't see it. And just by putting the hats on, then it's a tremendous force that will push me, or I will accelerate away. I'll absorb the hats and move accordingly. Yeah. So, but yeah, this, it just seems yeah, I guess I'm sitting here saying, well, I guess I'm in the middle, right? Because both sides seem very entrenched, right? The conventional physics is entrenched in they're not going to let go of Einstein's bent space easy. They don't, a particle theory of gravity, they don't seem too close to going there. Now, even though they're, well, you can't say they're not too close, because, like I said, who would have thought they would have done it for magnetism? So the fact that they are, I guess all I'm saying is when they say virtual photon, they're basically saying the particle part of photons. They're talking about rays, not waves. And, that's sort of important. Yeah. So anyway, so yeah, both sides seem very entrenched. And so, conventional physics has to let go of bent space as an explanation for gravity, because it's not an explanation. It's not really physics. It's inventing a fake dimension, space-time, that doesn't really exist. And it's putting a bunch of energy in that fake dimension, which is really a big mistake. So it's taking a bunch of energy out of this universe and putting it in this, the 3 dimensions, and putting it in this fake 4th dimension. And essentially, when you do that, your odds of unifying anything become 0, because there's no access from the other 3 dimensions to that 4th dimension, except when you're playing with gravitational notions of momentum. It just doesn't work. It only works in the big universe picture. It doesn't work at all in the small universe. It only works in the big universe picture when you cheat and use thought experiments to imagine what would happen, but you can't do the actual experiment. You can't actually speed up the matter to see the effects in the proportions argued to exist. Let's see. We have a couple of questions, it appears. What can this information be used for in an average person's life? Well, the truth is sort of important, so I guess I could argue that, if you think about different kinds of technologies and, different kinds of research that are dependent on chemistry, certainly physics is important to chemistry, so it might give you some way to, if you better understand the bonds between atoms, then you're going to better understand how to manipulate molecules to have them combine the way you want to. I think a right answer on understanding how atoms are put together might give you some better possibility or probability of finding fusion, for example, and finding other ways to glean energy out of atoms. So, it's just an obnoxious question. I'm really not liking you much, Patrick. Knowledge is valuable for its own sake, in the sense that you have a brain. There's probably a ton of things that you'll never use in your lifetime, but I think you're probably glad you know them. It's just stupid to sit here and, what good is this? Fuck you. What are you doing here? I mean, it's just such a dumbass person's kind of attitude. How can I turn this into a chocolate chip cookie? It's the truth. It's not a chocolate chip cookie, asshole. It's just so fucking irritating. I want to know if it can be applied to the creation of a propulsion system. But a propulsion system for what? I mean, I can explain to you how there's a speed limit in the universe. And I can explain to you how matter will never travel anywhere near the speed of light, any complicated matter, ever. It will be destroyed. It will be destroyed because every bit of radiation in the universe will have its frequency doubled by the time you're going half the speed of light. Yeah, well, what do you mean an aircraft? We already know the limitations of aircrafts again. They stopped making the supersonic transport, not because they couldn't keep making them, but because they knew there was no practicality to it. It's horribly expensive trying to go faster, and the fact is you're going through a medium. There's no magic. You have to push your way through it, and the harder you push, the more friction there is. But yeah, spacecrafts, you're never going to go anywhere near the speed you need to go to get anywhere in the universe. Complex matter won't survive the trip. The radiation will annihilate it. Besides the fact that, by my theory, your matter gets weaker the faster you go. So as you're being exposed to more radiation, at the same time, your material structure is going to be getting weaker and weaker. So it's not going to be a very good combination. That's why complex matter doesn't go across the universe. The stuff that showed up in our solar system wasn't complex matter, it was elemental matter. Little pieces of gold and little pieces of lead and little pieces, elements got here. Not complicated stuff, simple stuff. Now you explain the relationship between gravity on Earth and non-gravity in space. Well, non-gravity in space is an illusion, to some extent. Obviously, people think people on the space station are in zero gravity. They're not really. They're accelerating through gravity and creating a false gravity. They're actually falling, okay? But they're compensating they're in free fall, but they're compensating for it by their velocity. They keep trying to drive out of the free fall. You know what I mean? You can go, if you're in free fall, you can go sideways. So as you're falling, you can go sideways. Sideways, you won't notice as much, but it'll keep you from falling. So if you go this way on gravity that's in a fixed location, you sort of see what happens, right? You just keep bending around the gravity, but you're technically falling in free fall. But you're really not in low gravity. The gravity is still strong. If you kill your velocity, you'll notice the gravity is just as strong, and you'll start truly free falling, which is your spaceship will fall. So yeah, but if you go far enough away, obviously the gravity gets gets very weak fairly fast by the inverse square rule. But all the space people you've seen have always been in some gravity. It's not, it's not till you get out by the moon or something, the gravity gets kind of weak. But then the moon's gravity takes over. Okay, I guess I dealt with that much. Sorry, no offense, but gravity's really, you have to understand, gravity's not a thing. It's just it's the hat argument again, right? So the force on one side of you is wearing hats. The force on the other side of you has lost its hats. So the Earth is stripping the hats off the gravity, or putting hats on the gravity, however you want to look at it. And so now the two sides of the force that are next to you, it's the same amount of force. It's just now you'll notice it. It affects you. It'll accelerate you. So, but that's all you're really talking about. Gravity is just an imbalance created in the pressure you're sensitive to. The pressure's always there. It's just that you have a sensitivity to certain pressure, and certain other pressure is invisible to you. And that's because of the electrons and the protons are the real things being moved by the gravity. They're the things recognizing whether it has a hat or not. Hat, no hat. No. Let's see. Puff, puff, pass, Monkster. Oh, that's just too interesting. I think we'll just pass on your participation, fellow. King Dingaling. Yeah. Just too interesting. People are just so fascinating. It's just, man, I just love people so much. Yeah. So, yeah. So, yeah, but it's just so obvious that the whole push idea that this now, that's just such a, I mean, gravity's just the place where you can start and you just say this is where they started physics, and they really just made such a mess out of it. Because the idea of the Earth being pushed down, not being pulled down, just makes so much more sense. And, it just seems, certainly by the 1900s, they should have been saying, yeah, let's really work on this and make it work, make the idea of a particle gravity work, because it's just too good. I mean, it fits everything, fits the inverse square law, fits everything. Mach gravity is what it's called, but I mean, particle gravity it works really well, except when you start moving things away from gravity. Then all of a sudden, you have all kinds of thermal problems. But like I said, if by making it kinetic, I've eliminated all of those. So it just works perfectly. And if they would have just done a little bit of work on it, it's just so obvious that that's the nature. And then, like I said, back in the 1900s, the early 1900s, they made this critical error of going with the Maxwell notion, that light is an electromagnetic thing. And so instead of basically realizing that there's a thing called the speed of force, and recognizing that light is just one of the manifestations of force, instead they made it the speed of light, and then they made light electromagnetic when it doesn't have any electrical or magnetic properties at all. Light will never, in no circumstance has a photon ever. I mean, if it was, then they could solve the problem in the two-slit experiment. See, if light was giving off some sort of electromagnetic radiation or something, well, then you could detect it. But no, it doesn't produce any effect. It only has the mass in the one direction. It doesn't have any electromagnetic component at all. Let's see, do you use this information for work? I don't know. What do these things even mean? No, I don't have a job at a theoretical physics institute. So yeah, I guess I can possibly use them for work. At this point, like I said, you're asking me to predict all of the potential, the manifestations I've spent exactly zero time worrying about, because to me it's irrelevant. The truth is the relevant mission here. Whether or not I can make you a better chocolate chip cookie or not, I'm not too concerned with. But I'm pretty sure it's probably likely that a lot of things can be done better if you know what the truth is. I mean, I think obviously if you're using a better map, you're more likely to get to your destination more efficiently. So at minimum, I'll save you gas, because I'm going to be giving you a better map, and you won't waste time going down dead ends and cul-de-sacs and all that stuff. But I really wish you'd drop it already. So irrelevant. So the Earth is being pushed into the sun by two means. No, it's not two. The quanta pushing the sun's gravity. The quanta pushing the sun's gravity. No, there's one field of quantons. Entire universe, this is the only thing the universe is made out of, is these little bits going the speed of light. Now the ones in matter are of a particular polarization, and they're held together in electrons, protons, and neutrons. That's what makes matter. And so those little balls, schools of quanta, are being compressed into their one color. So I would say that electrons, you could just say they're made of the blue quanta, they got hats on. The protons are carrying purses with no hat, so they're red, say. Neutrons are going to be a mixture of the two, but I won't even get into that. And the idea is the field energy is pushing on them. So the little quanta from the field that don't have a hat and don't have a purse, if they hit one of those ones that has a hat, they bounce off, they reflect. And the same thing happens to the little guy inside. He bounces off and reflects. So he just keeps going back and forth, back and forth, back and forth, because he's reflecting off both sides of the field when he hits somebody who doesn't have a hat. But if a guy with a hat comes in, then nothing happens. So the universe advances as if nothing happened. And that means the thing going this way goes this way. And it means the thing going that way goes that way. And so, in a sense, the universe, for those things, speeds up a little and it expands. So the electron expands a little if hat comes at it. So you can sort of understand that if something's filtering out the hats, that the other guy's they're not going to get to them. So if they're reflecting off of me, if the non-hats are reflecting off of me and there's somebody behind me, he's never going to see a non-hat, if you get my drift. So the sun is just blocking, it's absorbing the guys who, it's changing the momentum. So the momentum's coming from the exterior, not wearing a hat. It hits the sun. Now the momentum's wearing a hat, and hat comes at me, okay? Hat is invisible to me, so I can't be moved away by it. I can't gain acceleration, but I'm getting hit by plenty of non-hatters from behind me, so I get pushed into the sun. And then vice versa, I cast a little shadow on the sun, so yes, the sun will move a little bit because of the guys I'm blocking. But clearly the sun's going to be the dominant player between us because I'm going to move a lot more than the sun. I think that answered the question. So the Earth is being pushed into the sun by two means. That's just the way you asked the question, was just kind of, both the sun and the Earth are being pushed into each other, but the sun is only being pushed by the minor amount of shadow the Earth is creating, and the Earth is being pushed by the major amount of shadow that the sun is casting on the Earth. So clearly there's a disproportion in who's moving towards who. Yes, they all have to move at the same speed or the whole thing would turn into shit, because the critical element is that photons are hat wearers at a specific frequency. So are non-hat wearers at a specific frequency. And you can't have a specific frequency if you didn't have constant speed. So without constant speed, there wouldn't be, a photon would never be able to go across the universe if there wasn't exactly a precise speed of light. If there was anything imprecise in the speed of a single quanta, it would just break the mechanics. How can you check? What does that even mean? Terra Mar, how can you check? Well, I just pointed out a check. The check would be as you can find a circumstance that makes it impossible for there to be divergence in speed. If there was divergence in speed, then it would create an irregularity or something you didn't expect mathematically. And so far, they haven't found any of these irregularities. So the movement of light is more of a reaction to energy changes? No. No. You got to understand that right now, there's as much stuff moving through me and around me, exactly as much stuff, quanta, as when a nuclear bomb explodes. Okay, now I know that sounds, what the fuck? There can't be the same density of quanta right here in this circle as there is in a nuclear bomb, but there is. And the only difference is polarization. When you release polarization, you're just releasing momentum wearing hats. And matter is a collection of exclusively quanta with hats. Now, the regular field energy, only 1 in 10 might be wearing a hat. Okay. So there's the same number of arrows right out here, momentum, as there is in here. It's just this momentum is all wearing hats, and this momentum isn't. Okay. So what light is just putting the hats at a certain frequency on a train that was going by anyway. The trains are all running. So there's just, if you think of it that way, there's trains going this way, there's trains going this way, there's trains going that way, there's trains. So it's all a bunch of stuff going in straight lines, and they never change. The train always keeps going. All you're doing is painting it. Okay, so when two trains go past each other, or they don't collide, let's just say they just look like they hit each other, all they do is switch colors. The train that was going this way, so if this was a blue train, this was a red train, well, now this is a red train, and now this is a blue train. So they just switch colors. And so what a photon is like trains going down a path, and the trains are at a specific distance, and they're at a specific color. So it's red train, red train, red train, all at the same separation and distance. But there's still lots of other trains on that track. Hopefully that explained it. Okay. So the movement of light is more of a reaction to energy changes. Right, that's this wrong. If so, then the electrons should change speed or stay within a range. Well, the electrons are a school of quanta. So they're like a school of fish. So obviously you can exchange fish that are going one way for fish going some other way. So that's basically what happens. A fish with a hat goes in and stays, so to speak. The hat momentum goes right through the electron, and some other hat momentum leaves. So it stays the same electron, it just accepts new momentum because it's wearing the hat. If it's not wearing a hat, then it just bounces off and changes the direction of the internal parts, but nothing in the universe has changed. Nothing in the structure of the school has changed. The school doesn't gain anything from it. But if it can absorb a hat, that means it'll gain the acceleration of that hat. It'll gain the velocity of that hat as a permanent, recurring. It's like you can't undo it as a fact. It's like if I have flipping heads and tails, I could sort of probabilistically say if I flip once and I get a head, and I put that down, you could kind of argue that I'm always going to be one head ahead, because, probability will come to roost, and it's like, well, because the first one, the default is always going to be one head ahead because the first one was ahead. It's almost like winning tic-tac-toe. Whatever one you get first, whoever goes first wins. And it's almost like whatever you flip first, you're probabilistically going to end up a million years from now one head ahead. So if you can get my drift, probability takes care of the rest. So once you added a fish of a certain momentum, that default condition, even if it vibrates, that default condition of one up one fish this way ahead is always going to keep recycling. So until a new fish comes in this way, you're always going to be that one fish ahead, which means the school is going to move. All right. Let's see, what's the source of the quanta? Oh dear. No, you're just not getting it. The matter's made of it. The entire universe is it's the only thing that's moving. Everything else that's moving is a derivative of the fish. So I'm basically just arguing the entire ocean is full of fish. You don't ask where did the fish come from. It's just silly. Okay, the whole ocean's full of fish. Over time, schools of fish form. And now the schools of fish function on a rule about interactions, okay, and how fish can get to them. And I'm just saying that obviously if there's a mechanism for filtering fish into these clumps, once you have that mechanism, then you're off to the races. Then it's just a matter of the clumps hitting a clump and then becoming a bigger clump, and the whole clumping rules. But there's no real point asking what the source of the quanta is. That's the same thing as saying what's the source of the universe. It's not something intelligent, I'll tell you that. It's a process, a mechanical process. And so as dumb as the simple rule is, which is little thing, only two properties. It moves the speed of light and it can wear a hat. It can be polarized. So that's it. You got two properties on a tiny little quanta thing that's all the same size. So you have a pool ball and you have a frisbee, okay? And it's going the speed of light, and it can be going this way or it can be going this way. But that's it. That's the universe. And asking where that came from, well, your answer is going to be even dumber or simpler than those three principles. Let's see. What's the source of the quanta? Stars, nuclear reactions? No. Wait, so what's the quanta again? Well, whatever. Fish. The quanta is force. When the quanta is collected into electrons, protons, and neutrons, we call it matter. What's being collected is polarization of quanta. It's not, how do I put this? It's the same force. It's just that the stuff, once it's matter, it means that it's a whole collection of clothes or turtle shells or, I don't care. It's a thing the momentum wears. And it's constantly changing because the field forces are constantly coming in. So who's wearing the clothes at any 1 minute, like this suit, okay, this could be a hat. The guy wearing it 1 second is going this way. Then it hits something. Then the next second's going this way. The next second's going this way. The next second's going this way. And the point is that it's going to stay essentially in the box because there's equal field pressure hitting it. So the stuff that's going to be stealing the hat is always going to end up doing this corner to corner thing or back and forth thing, or however you want to look at it. It's just going to keep doing that because the external pressure is going to keep it stuck in this little field of movement. Oh dear. I mean, what's the difference between qualia? We're not doing that. I mean, I don't know whether you really don't. I guess you really just don't understand what this is. But this is physics. Qualia is a discussion about what a 1 billion neurons can create as an illusion. That's what qualia is. Qualia is something a brain does. Nothing else does it. Brains do it. Anyway. Okay, fine. I didn't know you had a theory on the source or not. Yeah, no, I don't. Well, I have theories, but I'm saying I have made up stories about how I think it could have happened, but it's just no point because it's made up and it's based on so little evidence that there's really no point. I mean, I guess the idea of saying, okay, let's say you had a universe. We know how difficult perfection is, right? For us to do something perfectly. And so it's hard to make a perfect anything ever. And so the fact that the universe would have whoops in it, and that's what I would argue the initial Big Bang was, is that the universe does nothing forever and ever. And whoops, it whoops. And there's an error. And error is, there's a zillion gazillion of these little tongs flying around. Something like that. It's a fart. The universe, we're a fart bubble. I could give you the fart bubble theory. Yeah, yeah. Hot, smelly fart bubble. Well, Higgs boson is kind of bullshit, actually. I mean, they even say Higgs field, right? So it's like it's not even a thing. It's just some kind of radiating, magnetic-y kind of thing that kind of holds everything together because they can't figure out how everything's held together. But it's basically, dark matter with a different name. I mean, it's they didn't find the Higgs boson, right? They found its second cousin. And so they assume the Higgs boson must exist because, well, you can't have a second cousin unless you exist, right? So, yeah, it must exist because, we found some relative of it. But I don't think that, the standard model is a pile of crap. So I wouldn't, you know how they found the Higgs, this is the process, right? They do the experiment and then they have drawn a picture of what they're looking for, like Richard Nixon. And then they go through 1 million or 563 million images of cloud chamber emissions, and they see if they can find Richard Nixon. I mean, it's that silly. So I'm sure if they went out looking for the Richard Nixon particle, they probably could find one. I mean, it really is Rorschach kind of crap, If you look at enough of them, you'll finally find one that looks just like your penis. Well, I don't know. You want to ask the same question again? That's being redundant. Yeah. Well, okay. It's the same question. It's just nobody said anything else yet. I get that now. Yeah. I was fooled for a second. So, anyway, where was I? Yeah, I mean, I can't. Obviously, I'm not the best authority. I'll say that to explain the Higgs boson because I don't entirely understand. All I know is that the process of finding it was just about looking for a pattern match, and which is almost as bad as that whole gravitational lensing thing. They're really not finding it in real time. They're just going through things with a algorithm software like Google or something, and they're just looking for something that matches their Richard Nixon face that they've drawn as this is what we're looking for. And frankly, I think anything they draw, they're going to find one eventually. I mean, you could take any song like Start Me Up, you're going to make Jagger song, and I'm sure you can get the universe to say that. So if you go through enough of these little noises they're hearing, you'll find one that matches Mick Jagger saying, Start Me Up. Well, I think it's kind of obvious. I don't think God exists. It's preposterous. You just can't get more silly than an intelligence sits around forever, the uncreated intelligence that has existed for an infinite amount of time. And the thing that existed for an infinite amount of time just all of a sudden one day says, "Oh, I'm lonely. I want some animals to torture." What do you think the odds of that are? Yeah, I think they're pretty slim. I don't think something that existed forever could ever possibly have something like an idea. I think they've already done all of the ideas. Well, string theory and the multiverse are sort of in two different categories. Well, string theory is rubber band theory, and so that's eliminated because it's just plain silly. And the multiverse, yeah, the whole two-slit interpretation crap is just silly. Photons, the Heisenberg is bullshit. Photons have an actual location. We just can't see them. And there's no collapsed wavy thingy. There's nothing's getting collapsed. There's no opportunity to create new universes every zillion seconds. The whole idea of it is just so fucking idiotic. Well, I suppose there is a connection between string theory and the multiverse because they have to create extra universes because they have to explain where the rubber bands came from, or something like that. They have to tie the rubber band to a mule in the other universe to make it stretch, so they have to create another universe to tie the rubber band to so they can make them all stretch. It is really bizarre that all of these theories are so silly on their face. I mean, they're just they're silly. Like, I mean, if somebody said leprechauns are pushing the planets together, everybody'd say, "Well, that's stupid. They don't even have wings." And if they said, "Well, angels are pushing the planets together," they could say, "Well, that's stupid. It's just stupid. There's no angels, you idiot. How can they fly in space? There's no air. Their wings won't work. I mean, it's just totally ineffective." I mean, all these theories are just so bad. Bad. No, just shut up. LOL guy, I'm just going to block you. You're going to ask dumbass questions. You're just wasting my time. I mean, any person you ask, "Do you think UFOs is real?" And if you ask that to somebody, you basically just said, "Are you a complete asshole? A stupid, fucked-hearted lunatic?" I mean, God is a bad idea, but UFOs is just, that game is so over. So entirely over. I mean, you might get away with that crap back when they didn't have cell phones everywhere, but it's over, okay? It's just over. I mean, even if there was another civilization, if it was going to send something to us, it would send probes first, little probes. But nothing could ever get here. I mean, the physics is physics, and nothing's going anywhere. Let's see. You touched on speed traveling through the field. I don't know. That doesn't sound right, but I'll let it go. I understand that more speed equals more resistance. Well, speed and resistance only exist for material objects, things that are schools. So you have to understand the quanta doesn't have any speed issues, doesn't have any friction issues, doesn't have resistance issues. Only the school can have issues because it has to travel through a medium full of fish. So the school of fish has to travel through fish. Okay, so it can't just plow through the fish. It has to interact with the fish. The field has to allow it to move. The field, it moves things. Things don't move on its own. If something's moving, it's because the field moved it, not because anything else did. So let's see. So I understand that more speed equals more resistance, but would there be a way to circumvent this problem possibly? The only way you can circumvent it is you would have to create matter out of non-hat wearing or non-purse holding quanta. So you'd have to change the fundamental nature of the hostility, okay, between the quanta. So in a sense, you'd have to make them all compatible. So they'd all have to be wearing hats, or they'd all have to have purses, or they'd all have to have nothing. But they're all wearing clothes, or they're all naked. I don't know how exactly to say this, but they'd all have to be of the same polarization to be able to migrate through each other without interference. I guess is what I'm saying. The momentum is fine. It's the polarization that's getting stuck. The momentum goes through everything, but the stuff that has the information in it, so to speak, is the polarization. What color the train is the only way you can see the trains. If the trains didn't have a color, you wouldn't be able to see any of them. They'll all be gravity, and they'll all just go right through each other. There'd be nothing to see here. So the only way you can see something is they have to acquire the polarization. The filtering has to be possible for you to see. You have to make a distinction. You have to turn. I mean, I shouldn't even resort to human examples, but I mean, you have to make people black and white before you can have racial conflict, kind of a thing. You can't notice difference until you make a difference. Yeah, so the matter would have to be made out of something compatible with gravity. It would have to be anti-gravity matter. So whether that's possible or not, I would argue it's probably not possible because there's something specific about polarization that makes matter possible. That's the nature of it, is the very fact that it has filtered out. The blue has filtered into clumps and the red has filtered into clumps, creating electrons and protons. And the very fact that it has filtered out of the field energy, that all the red, say if the original field was empty and it had three colors, green, red, and blue. What I'm sort of arguing is that all the red stuff clumped into protons, all the blue stuff clumped into electrons. And now you have just green stuff out in the field, okay, except where the momentum, okay, of the blue and the red is still in the green now. So there's just more green. So green is the default naked, and the others are wearing clothes. I don't know how to exactly metaphor that yet. But it's the polarization is the argument, is that the polarization has been filtered out, and there's it now makes the elements hostile to each other in a sense. The polarization is segregated, and the boundaries of that segregation are strong. It's like the slum can't spread, and it's like the privileged areas can't spread. You know what I mean? It's a hard border between matter and force. And you see that you see the significance of it. Like I said, with a nuclear bomb, what you're basically doing is just allowing the momentum to carry the hat out of the matter. So now the hats are all being released back into the field. And it's significant because the matter wearing a hat accelerates all the other matter around it. And so all the matter starts accelerating, and all that acceleration causes it all to basically annihilate, to break apart. So you eliminate the borders, and the mobs are set loose, and they burn down all the buildings. Bad metaphor, but I used it anyway. Yeah, it is sad. That's what's sort of annoying with the position I'm in now, is that I'm really far into it, so it's all so obvious to me. So I'm like, okay, oh yeah, I have to go back a few steps and kind of get the person up to the speed so they can really get what I'm talking about. And it's, because it is a little bit, when you start saying there's as much energy, in right here as there is in a nuclear bomb exploding, yeah, somebody's intuition is going to say that can't possibly make sense. But it just has to do with what color the train is painted. If the train is painted red, it will smash shit. If it's painted blue, it goes right through. That kind of thing. Yeah, whatever. Pseudo physics. Ooh, use the big word. No argument, of course. Gutless puke. So yeah, if somebody wants to argue in the room, I'll post you the link if you're to the room. But yeah, no, you have to you have to behave, or you're not going to play. I am willing to debate anyone who's got a ball or two and wants to defend conventional physics, which is kind of liar physics and fool physics and fucktard physics, and it's kind of a religion. Yeah, so it's religious physics, really. Heisenberg, Huygens. Go look up Huygens, Mr. Pseudo-physics guy. Why don't you go look up Huygens and then try to compose an explanation for why they would invent a fake principle that they only use in one circumstance, the single slit experiment, to contrive an excuse to create a second photon. So why don't you explain how that's not just basically lying, just basically making up absolute crap because your mathematics fails, because your diagram of reality is silly. I mean, single slit diffraction just blows up wave theory. It just makes it look ridiculous. Single slits don't create wave interference patterns in water, in maple syrup, in anything, ever. And so it's just a fraud. I mean, they do, of course, with light, electromagnetic radiation, but they're not doing it because it's wave interference, because two photons are going through and interfering with each other. Well, spirit science obviously doesn't sound like anything to even waste time on, but I mean, I wouldn't even call that pseudo physics. It's obviously not even physical, right? So it's spiritual, so it's obviously just religion science. Which is, an oxymoron. They should just call it fable stupidity. Yeah, which all it is. Fable stupidity. Childish drivel. But not far from Ken, right? So it's, yeah, not far from Ken's theory. The hyperboloid vortex of power. I was going to play some Ken video. Yeah, maybe I'll play a little Ken video. So I'll be back to you fucktards later. That's based mostly on geometry, flower of life stuff. I don't know how that works exactly, but no, whatever flower is, I think that's the name of the skunk in Bambi, flower. Yeah, so I think Bambi's a fable too. I don't think Bambi's a real story. Anyway, let's play a little Ken. Put on the screen share, maybe to add to your fun. Screen share. And start it. And then I'll have to do, I guess I could make it bigger. Well, I'll do that just so you don't have to look at all the stupid icons and such. So I think this is what he says, something semi-relevant, maybe. Make sure there's enough volume. Okay, let's go off to the races.
Okay, so there's no such thing as a static particle. That doesn't emit. A force carrier for EM, that's absolute nonsense.
Okay, so a force carrier for EM, so that's the magnetic radiation. Basically, there's no the electromagnetic radiation is just there's no point in the electrical part. Really isn't. The electrical part is the symptom of the magnetic part, so there's no point in even adding that. But anyway, it's magnetism. And that force is a radiation, and it's physics is actually conceding to the truth by saying virtual photon, because that's exactly how it looks in terms of what it does. It's like two light bulbs, red force, blue force, radiating, and they radiate in straight lines, and the forces are obviously inversely compatible, and that's why they create the effect they do. So I mean, it's like I said, very compatible with my theory. So yes, good for that reason. But it's also, why would Ken deny them moving towards the idea of making the field that he desires to create anyway, the ether? Because that's essentially, by saying virtual photon, they could have just said virtual dominoes are virtual ether in a sense. They almost could say that.
A dielectric pulse's inertia. Electromagnetic, or EMR, is transverse electrical magnetic longitudinal pulse perturbations of dot.
Yeah. So I mean, it's just so descriptive. It just pops right into your head, and you say, "Wow, I get exactly what you're saying." A transverse linear perturbation of dielectric. And he's going to say more. Like, that isn't enough. He's going to put more ingredients in. Oh yeah, it's so simple. Mother Nature isn't a crack whore. She's fucking stoned on opiates.
Dielectric. That's the only circuit by which nature can.
The only circuit, again, the circuit thing. They just keep trying to make it into, like, the electric shit. Like, there's a circuit somewhere. Where's the circuit between two magnets? Come on. It's just silly.
And create light is a field perturbation.
Okay, a field perturbation. Well, like a virtual photon, right? So it's which is kind of like, you could just say, a perturbation through virtual field space. You could come up with some kind of jargon to make those two things compatible.
Do you think that if a person is in the middle of a pond and they're flapping their arms and they're creating waves of what? In this case, we're talking about a field perturbation or inertia perturbation with longitudinal. Okay, obviously the waves go out from the person flapping their arms.
Right. So again, but does that explain light or any other force? Again, they don't spread. Light doesn't spread. The little rays coming off of a magnet don't spread. And you know, I mean, he's just in such denial that there's just overwhelming evidence of field lines. The fact that charges placed in different locations will be affected by these straight lines, and that they're vectors off of the distance from the red to the blue. Okay, so there's a clear connection between the positive and negative charge, and what will happen at any one location. You can just draw the lines and figure out exactly what's going to happen. The straight lines work. So where's the perturbation part of this? It's clearly two different perturbations that are creating the field energy that's moving the thing in a direction. And it's going to move based on those two fields. And if you take one of those influences away, it's going to move differently. So it itself isn't perturbating, but well, whatever. Just kind of silly.
Hands versus waves, all those electrical magnetic. Do you think actually anything is being emitted from the person in the middle of the pond flapping their arms, and the waves are emitting outwards and lapping on the shore?
Well, clearly the you don't get to do that for free. So if you do that for a while, you're going to get tired, because yes, you're pushing energy into the waves. The waves are a clear conversion of one form of energy into another form of energy. So you just converted energy. You didn't. So there's energy in the waves. It's silly to say it's just a perturbation in a counter space. It's actual energy.
Longitudinal perturbations, they propagate. The thing that's about longitudinal perturbations of fields is they propagate in a longitudinal fashion.
Well, again, then they spread in the whatever horizontal fashion. So again, describe to me how this wave does the laser beam thing. How does this wave just wave in one specific vector? How does it not spread, these waves that you're calling waves? It just doesn't make any sense to call it a wave. You got to come up with some other word. This wave is just too deceptive. Huh, wrong page. Yeah, what a surprise. I got a bunch of those here. Where the hell is my video? It's not updates. DraftScience. Let's see if that's it. That looks like it. Yay! I'm back. All right, I'll put the screen share off. That's enough Ken for now. Ken's a little rough on the stomach. Anyway, yeah, major ego issues. Well, I'm going to try to give him a major anal issue. I'm really going to try to, butthurt him as much as I can. Fucking cunt. I'm just so sick of these people. They're all over too, right? There's all these people who are in the fringe community like me, right? And they're all fucking cowards. None of them will face anybody face to face. They all run. I mean, I've emailed 3 or 4 of these people, and yeah, none of them will have any kind of. They're all chicken shit, and yet they're so arrogant. I got the truth. Einstein's an idiot. They're all like showing pictures of Einstein upside down or some other kind of shit. Oh yeah, I'm much smarter than Einstein. I'm this. I'm that. Yeah. I mean, and then Ken mocks people as they say, "Well, I'm smarter than Tesla," but he thinks he's smarter than Einstein. I mean, it's funny, isn't it? Yes, it is funny. It's so ironic. It's so fucking ironic. Anyway, let's see. That's based mostly on, okay, that flower of life is just based on circular reasoning, as most sacred geometry is. See, I don't know what kind of, that's the kind of thing I want to get to Ken with too, is I want to find out, does this guy know what determinism is? Does he understand? Does he think that any of these perturbations happen from nowhere? Like, I can make myself know how to play the piano by just wanting it. Like I don't have to obey the rules. I can just make stuff happen. I can make a perturbation in the medium. It doesn't have to be cause and effect. I wonder what his fundamental, what his underlying, I think there's a singularity out there somewhere with Ken. I think there's I think there's some gremlins, that the little demons of bullshit that underlie his connection to this woo. Let's see. Can I ask what's in your hand? I don't know. Is there something in my hand? Oh, probably this electrical thing. Yes, no, that's my um, nicotine dispensing device. Yeah, I guess that's what we could call it. Vaping. I'm vaping. Um, Ken has some major ego issues, like a vapor cartridge and power cord. Yeah, see, I'm too cheap to buy, the real stuff. So I buy these from China for 50 cents each, and just don't do this battery thing. I mean, I have one battery, but it obviously doesn't last all day, so I have to last 25 minutes actually, and so most of the time I have to go with the adapter and two hands. See, I could, right? I mean, I did invent a foot switch. So there's lots of ways to try to turn it on and off. But yeah, I should be able to just put an on-off switch on this and wire it, and then I could just do it with one hand. But yeah, I have physics to do. See, that's the funny thing is I used to do shit like that. I used to spend my day like wiring my lights and doing this and I don't do any of that anymore because I do this stupid physics shit. So it really has changed. The function of the house because I don't really pay much attention to living anymore. I don't watch movies, except for the ones running on the digital things, recycling. But yeah, I don't watch any kind of television or anything. I don't do any entertainment at all. So, but yeah, you can't win a Nobel Prize, wanking to hot chicks in movies. Well, I don't know. You might be able to, but I'm doubting that it'll be as productive. All right, he's talked about trans-Euclidean space. Yeah, I don't, the whole Euclidean. I don't. Why does people have to drag it all the way down to something? They keep doing this. Oh, you believe in Newtonian physics, or you believe in Stone Age, and yeah, well, a lot of that stuff is kind of obviously right. I could say water was wet, and yeah, that's a really old idea, water being wet, but yeah, pretty reliable. Once, and I was like, "Is that me in a wig and a dress?" LOL. Yeah, trans. I didn't get the trans part, but yes. Tells you a lot about his knowledge on maths. I don't really like the plural of math, but anyway, I know it's a British thing, but math isn't a plural. you know, you do mathematics. Math is the short for mathematics. No such thing as a maths. No. There's only one mathematics. And you do it or you don't do it. But anyway. Does he have a fully cited quote that Oliver Heaviside and Steinmetz denied the light particle? Well, that would be interesting to find, right? I guess I could do Google that one. I've researched Steinmetz, and so I know he was mostly high frequency, high voltage. So he's kind of like a Tesla guy. I mean, most of the work he did was in that area. But I don't really know Heaviside. But obviously, I think Steinmetz did work. I don't know how much theoretical physics he did. I mean, beyond the theory of electricity. Not that that's not related to these other subjects. I just don't know how. I don't know how well versed he was in two-slit phenomenon and whatnot. So I don't know. I mean, Steinmetz died in like 22 or something, so he sort of missed the big show. I mean, he was right on. He got the initial Einstein thing, but he didn't have much time to think about it because he was croaked. So let's see. Does he have a fully cited quote? Yeah, a heavy side. Yeah, I just don't remember heavy side at all. So I don't know what his contribution was. I was disappointed to see that Maxwell was really it was an ether nut, and but it explains a lot. Like I said, that he because like I say, I think he's the guy who kind of ruined light by making it electromagnetic. Because light went the same speed as magnetism, he decided to turn light into a magnetic thing. And he should have gone the other way around. I mean, they should have recognized that light's a force like gravity and magnetism. Light travels the same speed as gravity and magnetism, so light should be called a force, not light. I mean, you can call it light, but you have to recognize it as a force, the force of light, because it's the same thing. And that's why virtual photon being used for magnetism is sort of a concession that, yeah, Maxwell shouldn't have done this because this is about tons. It's not about electromagnetic. It's about tons. The little bits aren't electromagnetic. The electrons and the protons are electromagnetic. It's like it's just a level to. He applied the character to the part he shouldn't have given. The force obviously is the carrier, but the force, they're wearing the hats, but they're wearing a hat because matter made them wear a hat. Okay, because electrons and protons force them to wear it. They're not wearing it by choice. Have you ever fucked butts? No. Ate dick, suck ass. I don't know what had pussy is. You mean eat it for dinner or something? I don't know if I did that. Well, anyway, you've clearly now just made yourself clearly an asshole. So goodbye. Yeah. LOL. Jesus. Have I pointed out that I hate people? Yeah, I really hate them. Scummy, scuzzy little weaselly things that should be just squished whenever possible. Yeah. Oof. Killed them. Yes. We ought to pay aliens to do the right thing and put us out of our misery. Put us out of our embarrassment anyway. Let's see, I can't find any quotes on Heaviside. He's a great mathematician specializing in vectors. I'd be interested. Probably should dig further. Yeah. Well, the one thing I did notice about the vector thing that, it sort of bothers me a little bit, is that the fact that they did with Einstein, they created this fourth dimension. So the idea of the X, Y, Z, okay, that makes sense. But creating this whatever W dimension of space-time is really irritating. So it just, that screws up your vector math, in my opinion. Time isn't relevant in a sense that we already know that most calculations, what you're trying to do is either average what happens over a period of time, or you're trying to find out what happens at the exact instant of time. So, I mean, this whole idea of having a time dimension that would be meaningful is kind of meaningless because it really wouldn't be meaningful. I mean, you're either going to make a collection of point observations and then calculate an average, or you're just making a point observation at the beginning and the end to figure out what the what the cause is and what the effect is. But there's really no need to um, dimensionalize time, in my opinion. Even mathematically, I don't think it's at all constructive. But anyway, that's a side issue. But vectors get a little bit. I don't like that they did the. Now that I'm looking at this idea of angular velocity, and I was sort of ignorant of the fact that angular velocity just means velocity calculated in radians. So that's all it means. It doesn't mean anything. It just means that instead of describing the velocity in how many meters is being traveled, whether it's an arc or a linear thing, instead it's calculating how many radians are, and how many of these degrees, which is, radians are just, they're not even a good, I mean, it's doing the pi thing. It just doesn't even come out even, right? I mean, a circle ends up being 6.28 radians. What the fuck good is that number? Oh, a complete circle is 6.28. That doesn't help any. I mean, I think you should go for something, degrees. Even the 360-degree thing makes more sense. But even the 360, right? You just figure that how'd they come up with that stupid number? 360 degrees. That doesn't seem right. A circle should be some better number than that. I wonder what the original degree was that they ended up with that 360 thing. I mean, what thing were they using as a standard that they ended up making a circle 360 degrees? Because, yeah, you could just say, wow, they metric system that one. Make a circle 1,000 degrees, and then 90-degree angle is 250-degree angle. Let's see. I think your theory is interesting, but you need to work on it more. Just looking at Wikipedia links for a year won't. Well, I didn't look at Wikipedia links, so you're a fucking idiot and a cunt. I watched MIT lectures. I watched Stanford lectures. I watched Yale lectures. And I watched all of them. Not only 801, but 802 and 803. And I watched some of them multiple times. So you can just fuck yourself in the ass, you fucking cunt. I did it for 4 years, actually. So fuck you until dead. Really, life is awesome. 22, you're a fucking piece of shit. And I actually sincerely am telling you this, I hope you die miserably, you piece of shit. God, that asshole needs a good kick in the ass. Well, I mean, realistically, I would predict that human being will never do anything on this planet that could ever be called productive. They'll always just be a little piece of scum. That's all he'll ever be, is just a blight, like an AIDS virus. And like an AIDS virus, we should pour hydrochloric acid on his fucking head. It should be a constitutional obligation to kill menaces to civilization. Anyway, time as a dimension is just a trick to carry time information for calculating world lines. Well, I don't know if that makes any sense to me, so I'm still going to argue. I don't think it's at all necessary. I really don't. I mean, you can do calculus without making time a dimension. Paths in the maths for relativity. Well, again, relativity is a flawed theory, so I don't see any point. A vector dimension is like an array of 4 slots of info. Well, again, I already know that. I'm just saying the info of time is irrelevant in terms of there is no way to calculate it without doing the permutations. So it's useless information. Something has a location in space. It just does, and then it has a vector that you can quantize by a standard, and that's it. Time is irrelevant. 360 degrees drive from the Earth's revolving actually, since it takes approximately 360 days to do so. Okay, well, I'm just saying that's kind of an arbitrary way to acquire the number then. So yeah, that's oh no wonder why the number sucks. That was a real dumbass way to acquire it. Yeah, I think they need to fix a lot of physics, and not only the stuff that's just I'm talking about that's really broken, but I just mean the mechanics of physics. They have like 15 or 20 different ways to calculate the quantity of energy. We got Kelvin, and I'm not going to remember them all, but you know what I mean. It's like a calorie, um, ampere. I mean all these different things, and it's just I mean watt, and which I mean they just got tons and tons of them, and it's just silly to have so many ways to express a quanta of energy. Um, just really broken. And like I said, I don't think there's much point in having distances measured in arc seconds and you know radians and meters per second, and I just no too many. Let's see. In order to improve this world, we need to get rid of niggers and sand niggers. Oh. So the whites can change this world for the good. Oh, you mean all those little NASCAR super cool white trashy from Alabama and stuff? Yeah, they're so Mississippi whites. Ooh, yeah, they're so cool. I can't wait to shoot them into space. I'll shoot them right at the aliens. Yeah, that'll provoke a war. Uh, Oh, that's such a classy name. He calls himself Pierrot's dead daughter. I mean, that's just wow. You really can't shoot that fucker in the head too fast. You just can't make it. The cops can't make a mistake when they shoot that fucker, right? I mean, uh, you're just saying there just can't be any use for that person. You just can't have any function on this planet but except to be like a causer of diarrhea or something. He's just a blight. Ugh, humans suck. I mean, if I pointed out, I mean, humans just suck. And all of you good humans out there saying, oh, I don't suck. You suck because you won't say what I'm saying, which is we should kill these fuckers. Okay, you want to just fess up. It's time. It's time to take out the fucking trash. And the internet is just beautiful. It's a beautiful device for trapping them. I mean, they'll come out, they'll out themselves. You can know where they live and go get them, man. Just go out with your gun and blow their motherfucking cunt brain into a million little fucking goddamn splatters. Because that's all they're good for, is making splatter patterns. I mean, we really, these idiots probably have guns and stuff. That's how great your laws are. You've probably given guns to these assholes who would call themselves Pierrot's dead daughter. Name was Juniper. People really should have a minimum of respect. Doesn't take much. I mean, you don't have to be a nice person. You just don't have to be a maliciously skanky, diseased cunt. So, let's see. We got more trollers. How's that stroke working for you? Hopefully you won't die next time. Well, I didn't die the first time, idiot. So, gee, it's kind of a silly thing to say, but now you're just proving that physics really is probably way over your head. you know, Emendum stroke, LOL, die next time, faggot. Yeah, well, whatever. I fortunately have the forces with me, quite obviously, so I can wish things and there's some chance of them happening. Your little silly wishes, I don't think will ever come true because trolls don't have, fairy god cunts. Yeah, the animation is, well, it's difficult. So, it's both a programming issue, obviously doing 3 dimensions and 2 dimensions, and obviously trying to do, uh, diagonals in square geometry, right? I mean, the real world isn't a checkerboard. The diagonals aren't longer distances and all that kind of stuff. So it just gets a little bit tricky to figure out all the balanced mathematics of how I create this grid work that actually functions and simulates the actual thing. And the truth is, you have to really have your programming pants on, and I haven't been wearing my programmer pants lately, and so it's just been a little tedious so far. So maybe I'll have a brilliant day someday, and it'll all fall into place. But so far, it's just been a little bit tedious, and so I'm thinking of just doing an animation instead. But we'll see. I mean, I really would like to have it be a mechanical, mathematical program, but yeah, just even thinking about it, I'm just tired, I guess. So I gotta just wait till I have a power up day. Well, I don't even know what that means. Did the stroke give you 30 different personalities as well? No, I don't really know how that's even a meaningful comment. I've probably been the most consistent jackass on YouTube ever. And the guy's accusing me of having multi-personalities. I mean, just amazing. I mean, every human has, people inside of them, but mine are relatively consistent people as a whole. Yes, 3D space would be cool. Yeah, so yeah, I'm figuring on doing 2D animations, not 3D animations, but we'll just see. Time will tell, but yeah, don't expect it tomorrow. But it really will clinch the deal. I mean, once I show people electrons and protons actually leaking energy and doing all this crap, they'll be like, oh fuck, that's just too good. So anyway, I guess it's probably time to say goodnight. MIC-KEY. Why won't my light turn? Broken. we broke it. Oh, there we go. KSWY. Mickey Yucky Wise. Such. It was actually a sad song when you think about it. The old Mickey Mouse song. Oh, see you next time. That'll be a while. Oh. While you do physics, I am getting warm pussy, faggot. Yeah, right. Prove it. You're a cat, right? You're petting your cat. Probably should take it away from you because you're such an asshole. Yes. Well, I hope you get what you want. It says he wants to die as a screen name, so I hope it happens for you soon. Anyway, God, I really do hate people. Scum, scum, and scummier. So, yeah, that's enough for this evening. So, yeah, hopefully Ken will make some kind of video I can laugh at and mock and ridicule and point out how he's just a dismal fucking coward. A petty, weaselly coward. Who can only pick on dead people. Fucking, ultimate pussy. Somebody's a dead person bully. And such. Anyway. And I don't think there's anything else to add, right? Just moving along, piece at a time. Push, push, blah, blah, blah. Eventually, eventually, I'll get the job done, I think. I'll endeavor to persevere. And then I'll persevere. So it works, right? First you endeavor to persevere, and then you persevere. So that's the plan. Old Indian taught me that. Old TV Indian. But anyway, it's as good as any Indian, right? Yeah, TV Indians are probably better than real Indians anyway. Yeah, real ones are probably smelly and such. Yeah. Yeah. All right, I am going. Just take my time. Drifting over towards the button there. Stop broadcast button. Yes, yes. I think I probably hit that. Yes. Stop broadcast. Yeah. Yeah, that looks like a good idea. Yeah. Yeah. Anyway, probably not till Saturday. I'll take tomorrow off and such, probably. Yep. And then maybe Saturday, maybe Sunday. I don't know. See how it goes. Got a lot of shit I gotta do this weekend. Yeah. It's under the house today again. That was no fun. Yuck. But yeah, I'm tired. My eyes are kind of droopy. Droopy eyes. Droopy. Tired. Ooh, Hannibal Lecter. I think we ought to kill all the motherfuckers, all the fucking trolls, you fucking cunt bitch. Why don't you just kill trolls instead of harassing me? Hey, I want a cupcake. I've been here a long fucking time, no cupcakes, fucking bitch. Why don't you just give me a fucking cupcake? I'll sign whatever, I'll read whatever you want, I'll do whatever you want. Give me a fucking cupcake, will you, bitch? Yeah, snacks are really hard to get in here. Get any potato chips? I could eat your face with potato chips. Yeah. A little bit of face, a little potato chip. Yeah. Well, maybe I do have more than one personality. All right, it's possible I have more than one personality. It's possible. Oh, I love Hannibal Lecter. I love you, love you, love you, love you. Oh, Hannibal. Oh. That's what I need. I need superpowers. I can't smell your cunt, but you have Cheetos. You've had Cheetos today, didn't you? You had some. You have Cheetos in your fucking car. You came in here, and you didn't bring me any Cheetos. You fucking cunt. Jesus Christ! I'm so gonna kill you when I get out of here, bitch. Shove Cheetos in your fucking decapitated head, fucking bitch. Yeah, probably more than one personality. Anyway, yeah, whatever. You can hang around as long as you want to, little gumdrop. I hate those. Whatever that thing is, it looks like a duck's head, little decapitated duckling. Ugh, I don't know why they invent things like that. I hated the smiley faces, but I really hate that thing, whatever that thing is. It's just so fucking. Yeah, yeah, it's herpes or something. Little smiling herpy. Anyway, okay, now I'm done, pretty much. So, till the next time, a little bonus drama movie thingy. Yeah, I do love it. Oh, Hannibal's back. I love Hannibal. Go kill him, Hannibal. Get him good. Yep. You really just can't make a mistake killing humans. You just can't. No errors are possible. Yep. Oh, there's the. Yes, there she is, Angela and such, um, and so forth and whatnot. Hanging there and whatnot and all that, you know, really is just. Uh, be nice just to sleep for a few hundred years. Anyway, where did and such come from? Well, I don't know what that means. That's not a proper sentence. Let's see. Oh, I just caught it now. HV, a good weekend, LOL. Yeah, I don't know what that means, but Oakley Oak, HV. Oh, I guess it's have. Yes, okay. Such and such dictionary, yes. So forth and whatnot. Okay, so now I'm going for real. Hannibal keeps drawing me back. Keeps pulling me back in. Hannibal gravity. Hannibal. Fly away. Fly, 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 fly. Fly, 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 fly. He's going to do the little fly, 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 fly part. Fly, 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 fly. Fly, 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 fly. I'll kill you later. Oh, I love that. Anyway, till next time and such. I'm going this time. You think you can dissect me with this blunt instrument? You stupid bitch. Cunt fucker bitch. I'll kill you later. Anyway. Yeah, debate hawking. Oh, that's pretty funny. Oh dear. Shit. Yeah, the talking machine. I mean, I wish Hawking was actually a good physicist, but he really isn't. So yeah, don't know what to say on that subject. So till next time, and so forth and whatnot and such.